Good morning everybody, myself Acharya Vishvendra, and today I am giving you the solution of quiz of the day today. So the topic we have chosen is AC circuit analysis. So here is a series RLC circuit in which current versus angular frequency curve is shown to you, and you need to find the angular. First thing is frequency for which current leads voltage. So current leads voltage, that means capacitive dominant, and from the concept of resonance we can say that here XC is greater than XL in this domain, and in this domain XC is less than XL, and at this particular frequency XC is equal to XL. So the same concept is used over here. So frequency for which current leads voltage, or we can say that XC is greater than XL, so that corresponds to angular frequency less than 10 is to power 3 radian per second. So that will be the answer to the first question. Next is frequency for which voltage leads current. So voltage leads current corresponds to this region for which angular frequency is greater than 10 is to power 3 radian per second. And next is frequency at which voltage and current are in the same phase. So it corresponds to resonance, which takes place at 10 is to power 3 radian per second. So in this way you can solve these questions easily. These questions have been asked many times in NEET and JEE Main. And here the important concept is of the resonant frequency, which is given by omega naught is 1 by 2 pi root LC. This is in fact resonant angular frequency, which depends on inductance and capacitance of the circuit. Sometimes questions are being asked like if I made inductance 2 times and capacitance 2 times, then what will be the impact on resonance frequency? So we can say that omega naught dash will be 1 by root 2. This will be 2L, this will be 2C, so this will be 1 by 2 root LC, so that means omega naught by 2, so it will reduce to half. So this question has been asked many times that how resonant frequency will vary with change in inductance and capacitance. One more way is, suppose I made inductance 4 times, so what should be the change in capacitance so that omega naught remains same? So if omega naught is same, we can say that L2 C2 should be equal to L1 C1. So L2 here is 4 times, then C2, then C1. So we can say that C2 is equals to C1 by 4. So we have to reduce the capacitance to 1/4 of its initial value in order that resonant frequency remains the same. So this is how things can be done. Now there are some interesting questions, applications of this. Suppose somebody asks you what is graph of omega naught versus L. So it will be like this. It will be having a shape like rectangular hyperbola. However, if you draw the graph between omega naught versus 1 by root L, that will be a straight line. Similarly for C and 1 by root C, the graphs will be like that. So this is analysis of the circuit, and if you have any doubt you can ask in the comment sections. Thank you and have a nice day.